Okay, this is the little addendum to 8.1. Uh, in the other class, I just talked to because we actually had a few classes and they knew what the deal was, but I need to talk to you guys. Okay, so if you look back through the book for the 8.1, problems 1 through 16, and you check your answers, the odd ones in the back of the book, or if you have a teacher's edition, you check the even ones, you will notice that I don't have all the answers in my notes. Now, I already warned you guys that I would leave some of the notes that way to kind of keep track of who's doing what, but the biggest reason I only have one answer is because I rolled through those problems and I only did the first easiest straight up answer. Because I think you should teach similar to how you coach someone in sports, which means you don't make it too hard when somebody's learning. And this is the beginning, this is the learning process. This is the very beginning. If you decide you're going to do it, you do it. If you end up having to do it, you learn to do it. But when you start out, you don't bog people down in all these little details. You don't tell a runner why they need to do the sideways crab run to strengthen their ankles. You just make them do it. But you don't make them do other stuff until they start to ask. If they really want to be good, they'll ask to do more stuff. When you teach someone to ride a horse, you focus on a few small things, and then as they get better and those things become automatic, you add more details. When you teach someone to play soccer, you don't teach them tricks. You teach them to play, you teach them the rules, and then when they get good and comfortable, then you teach them tricks. Math or any subject really should be the same way. You need to get a chance to fiddle with it and get good at it before somebody bogs you down in all the little nitpicky details. So, part of those nitpicky details is that there are two answers to a lot of those. Like number 3, for example. Now, I don't know how you all did geometry. I know I don't teach constructions anymore because they told us not to. I actually teach them in my math for people that hate math class because they're more fun than actual math. But that is the easiest way to show someone that there are two triangles. So, on number 3, I tested all mine out by doing constructions. The way you construct a triangle is you draw a horizontal line across the bottom to work from, your working line. I put in the angle they gave me, because they only gave me one angle. Then I drew a line up through there. Then I measured off the appropriate side. That is why, actually I didn't do it on this one, but on some of them where I put in the angle, I would write something like side A goes here. Because if side A goes here, then this has to be side B. So in this case, I marked off B at 34, and then, and I did all this with a ruler and a compass and a protractor because this won't work if you're just hashing it up just to get the lay of the land. It only works if you're kind of particular about it. Then I took my compass and set it at 24, is it 20? Yeah, 24, which is the length of A, and I drew that little sweeping arc, which means this makes two triangles. It makes this one, the big one, which is the one you find first, but it also makes this smaller one in here. So there are two answers to 3. Now, if you got one answer, that's fine. Eventually, if you do this for a living or if you really need all the solutions, you'll need both answers. If you don't, it won't matter. Even only half the answer is still worth half the points on the test. You would still pass if you did none of these second solutions. Okay, so I wrote down the first solution I got, just pretty much reproduced what was on the other notes, and then tiptoed through how to find the second solution. Now, here's another thing. Because this is trigonometry, because this is working on the unit circle, because this is all about the sine, cosine, and tangent, the book details this as to look at how many options have this being the same number. Sine being the same number because that unit circle, remember it repetes. That is not how I looked at it. I looked at this from a geometry point of view because I used constructions. My little construction makes an isosceles triangle that I don't need, but it makes one, which means the angle that I found from my problem, that 57.42, is exactly the same on the other side of that dotted line, which means I know that the angle that I need for my small triangle is 180 minus that. And that works all the time. They don't mention that in the book because they're trying to focus on what they're trying to teach. That is also a public school setup. Do it my way or the highway. That's where that comes from. What you do is you take the method that is the most successful, do the my way or the highway approach with the kids, students, and if you get good, you will learn that there are other options, that it's not my way or the highway. But not how public school works. It's usually not how you're taught to do it. So the second page of the addendum notes, I tiptoe making the second triangle. I have two angles, two sides. Same mechanics as finding out once you have that other side and you realize there are two solutions. Let's see, 4 had two solutions. That brings up another thing you need to think about that has nothing to do with math and everything to do with the fact that you are a student and have been a student successfully for 12 or 13 years at least. When you tiptoe through textbooks, you should have noticed that the textbooks, the odd problems are in the back, and that continues on up into graduate school. And the even ones look about the same, or they are about the same. The plan is that you take the odd one and you work it out and you check it in the back. And if you get it right, great. If you don't, you backtrack and try to figure out what you did until you get an answer that matches. Then you're supposed to have developed enough confidence to do the other one without knowing the answer already, or without having the backup or having the answer. Now I'm going to throw in this little short lesson on learning. Everybody learns the same way, and everything learns the same way. Monkeys, horses, people, dogs, cats, everything. If you have the capacity to learn something, you go through the exact same 4 steps as everything or everybody else. The first step is to mimic what I do when I'm doing it, which means if I put a problem on the board, you're copying it on your paper. If you can do that part, step 1 is down. The second step is to mimic what I've done after it's gone. I write the problem on the board, I erase it, you reproduce the exact same problem. If you can do that, everything's good. Step 3 is that you can do a problem that's close to mine, but maybe has different numbers. But you're going to do it in class. So step 3, 1, 2, and 3 involve having someone there who knows what's going on, someone that gives you confidence, somebody you can depend on. Step 4 is you can do a problem that looks close to mine without any backup, like the even problem in the textbook at home. All of a sudden now you don't have a teacher to ask, you don't have a textbook to check, you're on your own. That is how come stuff that seems so easy in class falls apart when you get to the house. But you need to think about that. If that's where it fell apart, 3 steps are done. You're stuck on step 3 of a total of 4 steps. There's nothing wrong with that. If you never get that far, probably nothing wrong with that either. Remember, you don't have to understand combustion to drive the car. You can drive the car. But that last step of driving or of doing this without someone to back you up, that is the very end of learning. That's where your understanding comes in. So don't argue about I don't understand this at the beginning when you're learning it, because understanding is not the beginning. It is the end. And if you do all this and you get stuck on step 3, that's 3 or 4. It'll be fine. Okay, so I did 4. Remember, it looks just like 3, just with different numbers. I did 5. 5 didn't work. I did my construction, and this is why you have to do the construction almost exactly. And I realized that my sweep puts me outside of a possible triangle. There is a rule about the size of that angle that it gives you. It generally needs to be somewhere in the neighborhood of 45 or smaller, but if you want to become a math major, then great, you can learn it. If you don't, you'll probably be fine not ever remembering that. I did 6. Oh look, 5 and 6 had the exact same issue. It looks like it might be able to make a second triangle, but when I construct it, I have the exact same problem. 9 was, 9 is a trick because it's an isosceles triangle. I think I talked about that in the other video about how experience gives you the ability to see that, but don't worry about it. 10 only has one solution. About 11, I was getting tired of this. Check 11. 15 only has one solution. 16 was not a triangle. Ta-da! But that was the extra piece. And I wanted to put this in here to point out that the way teaching works in the United States is almost counterproductive. I don't teach you something and give you a chance to do it and get it wrong. In fact, a lot of times, if you look on Facebook, all these complaints people have about Common Core math are about that exact skill, allowing you to do something and get it wrong just to get comfortable doing it. I mean, you don't give someone a baseball and they say they want to learn to pitch and you immediately hang a tire up on a tree. No, you let them throw it. You let them throw it wild. You let them just throw it everywhere. And somebody laughs and they put up with it and they tolerate it and they shag balls for you. And when you get better, then you become accurate. This is the chance I've tried to give you in the pre-calculus class. We've done it. I have given you all the examples and all the problems. You'll reproduce some for me. But you don't have to be perfectly accurate because this is a learning process. This is the beginning. I treat this like a practice. If it turns out that you love math more than you thought you did, or that you need it and you think you'd be good at it and you want to practice and become good, here's the addendum. And then there'll be chances in the book and other places to also get even better and then seek out help to be even more professional. But if you're not going to be professional, to be competent is fine. To be totally honest, if you don't ever do it again, I know loads of people who have money, have jobs, and are successful, and have never seen a pre-calculus book, and don't care to ever see a pre-calculus book. They make it. So that was the addendum I wanted to talk about.